Hello everyone and welcome to today's daily Leetcode challenge. I'll be solving question 1959, count number of homogeneous substrings. Also trying something new with the camera, let me know how this works. Given a substring S, return the number of homogeneous substrings of S. So let me go straight away to the drawing board. Given a string S, return the number of homogeneous substrings of S. Since the answer may be too large, return it modulo 10 to the 9th plus 7. This portion here is required for some languages, not for Python. Python doesn't have a limit on how big a number could be, but some languages do. A string is homogeneous if all characters of the string are the same. So an example of a homogeneous string, A, not hard. A substring is contiguous subsequence of characters within a string. So they've explained some terminology here. They've explained what a homogeneous string is, what a contiguous substring is. All of these terms are needed to properly understand the problem. And here's the problem in my own words. We have some string on the input that is not homogeneous. It could be, but it doesn't have to be. Certain portions of that string, certain portions, I'm referring to substrings, are homogeneous, meaning that I can cut out a portion of that string such that all characters within that substring are identical. In the example here, these homogeneous substrings that I'm referring to are A and AA, pretty obvious, BB, and CCC. Okay, now that I understand that there are homogeneous substrings, it is asking me, return the number of homogeneous substrings of S. Since the answer may be too large, return da-da-da-da-da. We've already been over that. So now I have to understand what it means to be a number of a homogeneous substring, right? Because, for example, in this example here, with A, BB, CCC, and AAA, I can come up with a certain number of homogeneous substrings that appear in this string. And they're actually already here. They're already here, but it might be a little bit hard to see why, for example, A exists as a homogeneous substring in this. AA exists as a homogeneous substring in this string, but AAA doesn't. Well, AAA doesn't exist in this homogeneous. AAA doesn't exist as a homogeneous substring in here because if you wanted to build AAA, you would have to the substring wouldn't be contiguous. And here we have a requirement that the substring be contiguous, meaning that we cannot cut out certain portions of the string. We have to take it as a whole simply by indicating a start and a finish. So now, if you wanted to dive a bit deeper, you can infer that a specific character's maximal contiguous substring length will be simply dictated by the largest occurring contiguous substring. In this case, for A it's 2, for B it's 2, for C it's 3. And given that we have this information, we're simply now counting the number of all possible substrings appearing in this input, contiguous substrings. So, given that we have this information, let's maybe move a little bit further away from what is this specific example and move to a more general solution approach. Let's see if there's another example that may be more suitable to talk about this. And I think that this right here is actually ideal. Here's the reason why. In this case, we see that z appears, 5 times? There are no interferences with other characters in the string, but the question pretty much still stays the same. How do we count the number of all the occurring contiguous substrings in this string? How do we find the total of that? So I propose that we actually go through and have this string here, 5 z's, and I want to know how many times does z appear in it, how many times does zz appear in it, zzz, zzz, and zzz. Because ultimately the sum of all of these will give me the correct response, right? The sum of all of these appearances in the original. Well, I know that for a string of length 5, the substring z will appear 5 times. And it's pretty simple, right? I go through and look through how many times this one character appears. For z, it appears 4 times. And maybe you can notice the pattern right away, but for 3, it'll appear 3 times. This will appear twice, and zzz 5 times will appear once. This may be a dead giveaway for some, but for others it isn't. What this actually is an arithmetic progression that is very often encountered in CS. Looks like this. This is the sum of an arithmetic progression. There are countless videos on how to derive that, but it's very simple. What am I claiming here that we can do with this arithmetic progression is we can say, hey, if our string is of size, if our homogeneous string is of size 5, then what is this going to be? 9, 12 to 15. 9, 12, 15. Well, 5 times 6 divided by 2 is 15. So we can simply get this, the number of occurrences by applying this arithmetic progression formula. And how do then we apply this to the solution? Well, we can start looking at, and let me go back to this example here. We could start looking at the different characters, homogeneous substrings that appear in our input string, and simply sum up the number of occurrences. This is what I mean now. When we look at this single string, we will do the arithmetic progression formula and we'll get 1. When we look at BB, BB is going to be 2 times 3 divided by 2, which is going to be 3. CCC will be 3 times 4 divided by 2, which is 6. And this is going to be 3 as well. And the sum here will be 13. The sum of all of these values, 13. So I'm pretty much suggesting that we go through the input string, understand how many, count how many different homogeneous substrings there are, and then return the sum. So if we were to implement that, I would start by having a sum and an end, a result, and something like this, while end is smaller than or equal to len of s. I want to have a way of iterating through through my whole input string and understanding where the start and end of each homogeneous substring is. I want to say that while s of start is equal to s of end, I'm going to say end plus equals 1. And let me see, maybe also end is smaller than len of s and this. Now I want to basically just to initially test, print out the if I'm getting all these substrings correctly. So s start end, and then cool. Once I have that, I would want to say start is equal to end is equal to, oops, this will probably be end plus 1. Let's print this and let's run this. I should be seeing A, BB, CCC, and AA. And I should be seeing this for all characters, but that's not yet the case. Now that I have the strings, the homogeneous contiguous substrings outlined, all I need to do is implement this formula that I denoted here, the arithmetic progression. That is going to be my n is equal to end minus start, and n times n plus 1 divided by 2. And I should print out the result. Let's see if this works for smaller numbers, and then if it does, then simply dividing this, doing a modulo of 10 to the 9th plus 7 should do the trick. Let's submit and see if this works. If so, then this is the solution. And yeah, hopefully this was quick and easy. I guess not the fastest. Let's see what others came up with. Although my assumption is that can't be that much faster. They're still using the same approach with the arithmetic progression, and the only thing that they're doing is using a built-in itertool group by function to get the correct cuts of the homogeneous continuous substring cuts. Yeah, I don't see much of an improvement in any of these solutions, to be honest. They all seem very identical. So you know what? I'm going to default to this being another one of those situations where the runtimes on Leetcode are just different from submission to submission. So with that, yeah, I would recommend you using this absolutely. This is extremely clean, straightforward. You know exactly what each of the variable does and what it is in each instance of the program. So with that, thank you for watching. I'll see you in the next video. Please like and subscribe. Thank you. Bye.